All right. Hello, everybody. Today is Tuesday, and it's Tom Dimitrovich for IAEI News Live. Hey, Nihad, good to see you. Steve, good to see you. I am trying to get my stuff together. I had to drop off of another call. I hope they know that I'm not there. Jason Doty, good afternoon. Also to all in the... Oh, wait. Where's it at? Oh, I can do a thumbs up. There we go. Jason Doty. Hope everyone's a wonderful holiday season. Yes, we're in the middle of a holiday season, and I think, if I'm not mistaken, next week, I mean, we're getting close to Christmas. I'm just looking at my calendar. Finally pull up my calendar. So the next Tuesday is Christmas Eve. So I got to figure out what I'm going to do for Christmas Eve. I can't go live. I don't know. I could go live. Anybody want to go live with me on Christmas Eve on IAEI News Live and have a good holiday session? Maybe I'll get some eggnog and all that jazz. All right. Oops. How do I hide the comment? There we go. Hey, we got Vince B, Jason Doty, Felix Sandoval. Welcome back, Felix. Hope everything is good with you. We've got David Engelhart in the house, and we've got Eli. Can't live without Eli being on the program. We got Laurel from Omaha. Thank goodness you are here. We're going to need you to do our research. Eric Hammond, good morning. Looking forward. Yes, another Tuesday. We're going to talk grounding and bonding today. And you know what we're going to cover is Yummy Fudge from Utah. We're going to cover separately derived systems today. So that ought to be fun. Yes, eggnog. You know what eggnog is, Yummy Fudge. Got to have your eggnog. And got to have a little rum in that eggnog, too, I do believe. Welcome to IAEI's YouTube channel. I hope we are screaming hot. We've surpassed 1,000. We've surpassed 2,000. We've gone past 3,000, 4,000, 5,000, 6,000. We are on our way to unbelievable heights on IAEI's YouTube channel. And if you're not a part of the magic, get out the house. That's what I'm saying. So Don Ganir, we got another researcher, Don Ganir, and Brian Kroll. Thank you from Iowa. I hope those Cornhuskers out there are doing well. So guess what? I don't know if I got this right. Nope, I don't. I've got to fix this. Brian, I've got to highlight you and take that off. And I need to switch my monitors. You know what I need is like a me and monitor 2. I have me and monitor, but it's the wrong monitor. I've got to switch this to not tertiary, but secondary. There it is. Look at that. Gosh, I love technology. Tell me, do you guys like technology? You know what I just set up? I set up my first NAS, my network accessible storage. I bought a Synology NAS. I got room for 5 bays. I have 3 20 terabyte drives in a RAID 5 configuration. Anybody want to do that stuff? Let me know. Trial by fire right here, buddy. And I also set up my own Linux server. I'm running a Linux Apache web server on it, and I'm playing and learning. You know what? The only way we learn is to do. And it's the same thing with grounding and bonding. You know, I learn by getting I take risks, calculated risks. So like on my Linux server, I had a PC laying around. It was an older computer. I formatted the hard drive, downloaded Ubuntu Linux server, installed it, got it running. I put Apache on there. I put what else did I put on there? I put a bunch of stuff on there just to get some fundamental things. I got a SQL server, all that jazz. I've been playing with it, and it was all free. I mean, all that the Ubuntu was free. Everything was free. So we have got to explore, play around with things, and every now and then, failure. Failure means success. Believe it or not, being wrong is not a bad thing. Screwing up is not a bad thing. Lying about it, that's a bad thing. All right. Oh, yes, and Eric Hammond. You know, I agree. Technology is, you know what? Here's the thing, Eric. So here's what I've learned. Oh, you got to love this. And I made this statement the other day. These things, okay, these phones, and I got Jake and Maggie on my phone. These phones, if you think about what we used to do back in the 90s, I would have to go somewhere or put something in the mail. Or if I wanted to research something, I had to go to the library, had to have a library card, and you checked out books, and you had, and I thought that was, I mean, I thought that the Rolodex or the what do they call that system, whatever system was fantastic in finding reference materials. And then they came out with this, and when this is slow, I mean, it takes like a millisecond to pop up, we complain. So that's the way it goes. I mean, that's just what we do, right? Oh, you gotta love it. Yummy Fudge says he's got a 105 terabytes and 2 servers with 6 virtual machines and more. You know what, Yummy? You and I got to get together because I got a lot to learn. I am having some challenges with mine, so that is what this channel is all about. It's about connecting and networking and all that good stuff. Card catalog, yes. Oh my gosh. So Jake came down. Jake's laying behind me on the floor. Maybe he'll get up and he'll grace us with his presence. But I want to talk separately derived systems. I don't believe... Let's first talk... What... So the slides that I am using... The slides that I am using are from the SOARES Grounding and Bonding. So IAEI, this is a fantastic resource. If you don't have it in your library, I have, these are just 2 of my references. I have the 2017 edition in my library, and I've got earlier editions too. And this one here is the... So this is the 13th edition. This is the 12th edition. So this would be the 14 code. And I go back and I got the latest. So I would highly encourage you to have... Sorry about that, Jake. I would highly encourage you to have your own... build your library out on SOARES Grounding and Bonding. Never hurts to have more than 1 copy and 1 edition. And I like having multiple editions because I'll compare, I'll read a little bit, like I read some of the older editions and then I read the newer editions. You know, we have different authors, different contributors throughout the life cycle of these documents. So the slides that I'm going to be looking at today are taken out of the slide deck for SOARES Grounding and Bonding. And I'm telling you, if you are in a chapter, you're in a division of the IAEI, you need to get on your agenda grounding and bonding classes and programs. There are 3 different PowerPoint slide decks, a wealth of information. Get on the stick. So let's talk separately derived systems. This content is going to be based on the 2023 edition. Yes, this is updated. It's fantastic. Chapter 11 out of this book is on grounding separately derived systems. Separately derived systems are all around us. I would say pretty much in every power distribution system, we're going to have separately derived systems. All the ways down to the doorbell transformer that is probably in most homes. I know we have a doorbell system which is disabled. We disconnected the conductor because when that bell rings, the dogs are a barking. So we don't want that. So you come to my house, you're knocking the old-fashioned way. But we do have a doorbell transformer in the house, y'all, and it's accessible down here in the basement, I believe. It's in the basement. So in the ceiling. So pretty much in every power distribution system, you're going to have separately derived systems. And I was on a call this morning, and you probably, some of you I know were on that session, and they asked me a question, Tom, what's the definition of a separately derived system? And I'm going to give that to you. I want to read it because I don't trust my own memory. I could probably spout some of this stuff by memory, but I ain't gonna do it. All right. An electrical power supply outlet other than a service. So we know a separately derived system is not a service. Period. When we identify a separately derived system, it's not a service. We have a definition for what a service is. And we take care of that as part of Article 230, etc. So an electrical power supply output that is not a service, having no direct connections to circuit conductors of any other electrical source, circuit conductors. We're not talking grounding and bonding. We're talking circuit conductors. That's your hot, your neutral, your grounded conductor, your hot conductors, three-phase systems, other than those established by grounding and bonding connections. So we're not talking about the grounding and bonding connections. We're going to bond everything together. That's not what we're talking about. We're talking about the circuit conductors. They don't have a connection. So if I think the easiest one for me, at least, I mean, I know others will say, well, the generator. Yeah, generator is a very clear example of a separately derived system when that generator is basically powering the structure by itself or powering loads by itself. But I look at separately the biggest and easiest example for me is I gotta move my phone because I'll put it on here because whenever it vibrates, I hear that. The other good example for a separately derived system, in my opinion, is a delta to Y ground transformer, delta delta transformers, Y to Y transformers, not a auto transformer, because auto transformers share windings between the primary and secondary. So that is the auto transformer is not a separately derived system. Your Y to Y, delta to delta, delta Y ground, etc. are separately derived systems. You have a source. You're establishing a source. That source will have a capacity. You're going to have a specific capacity that is capable of being delivered. In the case of a transformer, we know we have kVA of the transformer. And the generator, you're going to have kVA from the generator. And in reality, the kVA from a transformer, I would argue, is not it's not a cap. It's not like you can't get any more than that. Generators are only going to produce so much. A transformer, you can transmit more than its kVA rating. And that's why we add fans, and the only thing we worry about is the duration, the life of that transformer. So we'll push and we'll work transformers. We'll work them hard sometimes. And again, the harder you work a transformer, meaning if you're exceeding the kVA ratings and things like that, it's not that it just stops. You put the load on it and you have the source on the line side of that transformer, it's going to deliver power. But you have to have that capacity, that ability. And then you're going to have to protect. You protect the conductors from the separately derived system. You protect the source of the separately derived system, whether it be a transformer, a generator, etc. And then it's at that separately derived system that we establish our grounding and bonding. Now, some good examples of separately derived systems. There's your transformer. Gotta love the transformer. I mean, there's a workhorse right there. I mean, if that's not a fundamental piece of equipment that is pretty much found in every power distribution system that is an AC system, transformers are it. I mean, conductors, but transformers, come on, right? Very common piece of equipment. You've got you think about a wind system is basically a turbine. Think about what is a wind. Talk about wind generation. I'm basically turning the rotor with wind instead of a gasoline engine or a diesel engine or water. Right, so if I had a generator that I'm turning that rotor because of Niagara Falls or something of that nature, or I have a dam, and I'm pushing water through a turbine, or maybe steam. I'm creating steam. There are various ways to create steam. I could create a gas furnace. I can have some sort of boiler where I boil water, create steam, and then I push the steam through a turbine, turn that, and it turns the rotor on a generator, and then I'm generating power. All of those are generators. The prime mover is different. And wind, I mean, come on. It's wind. Wind turning the rotor of a generator. So, gotta love it. So there's your definition of a separately derived system. You have to be able to understand. You have to be able to identify. So this is where terminology is critical. And I've said this before. Remember, definitions might seem boring, but you have to be able to identify something by its definition. Once you've identified and it meets the defined term for whatever it is you're looking at, it could be a light fixture, a luminaire. If it's a luminaire, if you say, oh yeah, this meets the definition of a luminaire, you know exactly what article you're in chapter 4. If you look at that generator and you say, this is a generator, does it meet the definition of a generator? Yes, it does. You're over in 445 chapter, you're in chapter 4. Transformers, etc. We have defined terms, and that's your gateway to what your requirements are. Separately derived systems are no different. We have to understand the defined term, identify it in a power distribution system, and then we apply the rules, in this case, for separately derived systems. Make sense? An example of a system or transformer that is not separately derived, there's the auto transformer example. AC side of an alternate energy source that has a grid interactive inverter. When we say grid interactive inverter, when the grid shuts down, the inverter shuts down. Grid interactive inverter. It's going to be listed as such. Again, it's a defined term. Hopefully, at some point in all of these programs, you're going to gain, the Article 100 is going to gain your respect. Because I know for me, Article 100 was like, I just want to go to sleep. Until you realize how important it is. An example that is clearly a separately derived system, generator, standalone system, a generator. Now, if that generator is interconnected and you have a transfer switch, if you're switching the neutral, right? So this, I forget who it was. Whoops. Crap. What did I just do? I know I did something bad. I knew I did something bad. Look, I'm back here in the background. I have to go to source and blink. There it is. All right. I clicked a little button and I tried to get this up. There we go. Yep, definitely. So, man, you know what? My microphone was off. SDS means the system neutral is being switched. Yep. Separately derived system. Now, if I have a generator application and I have that transfer switch, then I am switching that neutral. Now I have a separately derived system in that generator. If I don't switch that neutral, I don't have a separately derived system in that generator. So very good point, electrician Ron. UPS systems can be separately derived. Yeah, good, very good point, Eric. Very good point. In there, David Englehart's pointing it out. Switching that neutral and a transfer switch. Oh boy, well, I was mixing a lot. I got electrician Ron. I got card catalog. I got Dawn Gannier. What Carl? Carl Lewis. What's Carl say? Is a solar panel or generator considered separately derived system? So hopefully, Carl, we just answered that one. So if for a generator, if I'm switching that neutral, from a solar or a PV perspective, if I have a utility interactive system, then I am not a separately derived system. Good questions. Good questions. Third edition of SOARES is in my library as well as some newer ones. Yes, I have that old one too. Before they added other than bonding and grounding connections, there was a lot more confusion as to what separately derived systems. Yes. Oh, I agree with you 100%. All right. I'm going to make sure I get up to speed. Definitions and scope are important. Jason, absolutely definitions. Then the scope of the art. Yeah. Oh my gosh, Jason and Yummy Fudge. You're right. So here's the other thing. Okay, hear me out. When we're talking anything in the code, you've got to understand your defined terms. You have to, understand your scopes, and then you've got to understand and have the perspective of chapter, article, the scope of the article, the parts, the scope of those parts, and then the section. So I can be in a section that I could misunderstand and misinterpret and think it applies in some applications, but it doesn't because I'm in a specific part of that article. So very important to have that hierarchy in there. So thanks for bringing that up. Yummy. Probably me about the generator. I've got one that is not a separately derived system, but most of the time it is, but in my case it's not. Yeah, that is, you know what? If you understand the defined terms, you'll know whether or not that's a separately derived system. Okay. 250. All right, I'm going to get my code book. Sorry, Jake. I know. You're a good boy. Okay, so Article 250. Man, I got stuff in here. You need your readers. Message number 1. We're going to be in Article 250, which is before Chapter 3, and it's after Article 240 and 242. 250.30. What is 250.30? Is grounding separately derived alternating current systems. So in addition to complying with 250.30A for grounded systems, or as provided in 250.30B for ungrounded systems, separately derived systems shall comply with 250.20. What's 250.20? 250.20 is alternating current systems to be grounded. It's in Part 2, System Grounding. And 250.30 is in part 2 as well, system grounding. 21 or 26 as applicable. So 21 is alternating current systems of 50 volts to 1,000 volts not required to be grounded. And then 20, 21, and 26, 26 says conductors to be grounded alternating current systems. Okay, so as applicable. Bye, Jake. Multiple power sources of the same type. Oh boy, he's going to go upstairs. I bet you he falls. He fell down the steps the other day. He slid down. Be careful, Jake. Multiple power sources of the same type that are connected in parallel to form one system that supplies premises wiring shall be treated as a single separately derived system and shall be installed in accordance with 250.30. Jake, come here. I just don't want him to go upstairs. You got A is grounded systems. You have A1 is system bonding jumper. Come here, buddy. Come here, buddy. A2 is your supply side bonding jumper. These should sound very familiar to, they should sound very familiar on your services side because we have supply side bonding jumpers. We do our bonding and grounding at the separately derived systems is very similar to your non-separately, to your service applications. Supply side bonding jumpers, grounded conductor, grounding electrodes, grounding electrode conductor, single separately derived system, grounding electrode conductor, multiple separately derived systems, and then you've got your ungrounded systems. Okay, so those are the areas. Jake is back there. All right. There are times when separately derived systems are not permitted to be grounded. Come on, buddy. If the system can be grounded so that the voltage to ground from any of the system conductors does not exceed 150 volts. Okay, so we got all of that stuff down. It's my buddy Jake is here. All right. Let's move. Let's keep moving. Up. Examples of the condition: 2 or more engine generators with paralleling switchgear. This is multiple sources of the same type. So this is your PV systems, your 2 or more engine generators with paralleling switchgear, etc. And we just read 250.30A1, and you have A and B of that. All right, so we know we have to decide when it's going to be grounded. Okay. Let's do this. I love pictures. Let's talk about pictures. Okay, so in this graphic, what you'll see, this is a transformer. We have a separation. New Jersey's calling me. It's probably the New Jersey governor. All right, so you have a transformer. You have complete separation of the primary and secondary circuit conductors. The grounded conductor, your 2 hots. The bonding is not separate, right? So you're bonding the grounded conductor with the frame, and on the line side conductors, you're bonding with the frame there as well. So you do have that connection, which is why the definition, and to Don Ganier's point, that definition had to change for clarity because we want to make sure that you will have common bonding from one side to the other. So that grounded conductor is bonded. And then you have your 2 hots that supply the panel. Now that says a service panel, but I don't necessarily have to have it doesn't have to be a service. I mean, this is just a separately derived system that wouldn't be a service. There's your typical, that's your transformer secondaries and primaries, but you'll notice that big conductor there is bonded to the frame. That's basically what's going on with that grounding and bonding connection there on the secondary. See that conductor has a white label to it, has a white wrap around it, and all that jazz. That's your XO. Jake. All right. Grounded or grounding. Yeah. Thank you very much, Yummy Fudge. It's bonded. It's oh man, you're so right. So in that image, in this image, I'm bonded. I am bonding my XO with the frame. I got to get back to my notes or my comments. If that is not a service, then you need a supply-side bonding jumper between the transformer and the panel. That is exactly right. You know what? You are exactly right. Let's go back to that image. But you know what I don't like about this image is it has it as a service. Now, Dawn, it says the graphic images may not show all conductors required for a compliant installation. I just wish it was a little bit more complete. But I don't disagree with you, Don. Install the system bonding jumper. So you have to have a system bonding jumper. You have to have the supply side bonding jumper. You have to figure out what you're going to use for your grounding electrode. That's in 250.30A4. Don't ever let your book down. 250.30A4. Let's go to 250.30A4. That is after 240. I just heard somebody comment 250.30A4. I don't know what they said, but we're going to first read 250.30A1, 2, 3, 4. That's your grounding electrode. The building or structure grounding electrode system shall be used as the grounding electrode for the separately drive system. If located outdoors, the grounding electrode shall be in accordance with 250.30C. So I've got, I have a decent, I've got a pretty good image, a picture too. I took a photo when I was in Alabama with Mr. Cook, Donnie Cook, one of my mentors, and we had a really good, there was a transformer. There it is right there. Look at that. Man, it's just beautiful. Let me see if I can do this. You don't want to see that. I have to hit escape. There we go. So this was a transformer installation. I really liked this because it had, you'll notice this is a transformer, right? And look at that right there. They have a rod right there at the transformer where they're doing their bonding. I just thought that was a really slick little, just a really nice picture. And it looks like I sat on the daggone thing. But I didn't. Somebody else must have. Hey, Laurel. Yep, this I took this photo in Alabama, and what I loved about it was they had the connection to the grounding electrode system right there. I might even have, whoops, a few other good pictures here. Oh, I found this. This one was interesting. That concrete connection right there doesn't look so hot, does it? Whoa, didn't mean to do that. If there is a transfer switch, thanks a lot for sharing. Yummy Fudge, unless it has a transfer switch, unless it has a transfer switch, I forgot the name, but one panel can be both if it has a hard switch to make the source one or the other, but never both. The name of the lockout device is fuzzy. There's a transfer switch on the line side of the panel. Then the transfer switch is the service equipment, not the panel. That's a true statement. That's a true statement. You know what I find that helps and works very well? I don't know about you guys and gals, but pictures. Pictures are worth 1,000 words, in my opinion. All right, I'm going to close that out, and let's close that out, and let's close this out. Let's get that PowerPoint back up and running with scissors. Why? You know what? I was waiting for that. How do I get back there? So I asked this, Eric, you took the words out of my mouth. Why was another ground rod driven for the transfer? Wouldn't they connect to the existing grounding electrode system for that building? And I would agree with you, Eric. Now, I can't remember where we were at in that facility. I highly doubt I was on the second or third floor, but in any case, they could have used that rod, connected it to the building steel or whatever they were using for the grounding electrode. But I don't disagree with you. I found it interesting that I had another rod. That's why I took a picture of it, because I'm like, wow, I usually see it bonded to, in fact, I know I have a few other pictures in which I should throw in this example, or just in the slide deck in general for the SOARES Grounding and Bonding. But you have to be connected to the grounding electrode system of that facility. Now that, I don't know what that rod connects to. I can't remember if we were in the basement and they drove a rod through the concrete. I don't believe they've established a separate grounding system for that transformer, because to your point, and to David Englehart's perspective, you have to have a common grounding electrode system that all has to be bonded together. So I don't get that one either. I thought it was odd, and that's why I took the photo of it, and I thought I would share it with you guys and gals. Let's go back to this. System bonding jumper connects the supply side bonding jumper of the derived system to the grounded conductor at the source. The system bonding jumper size is in accordance with 250.28D, based upon the size of the derived phase conductors, and 250.102 Charlie 1, or 12.5% rule, if derived phase conductors exceed the values. The function of the system bonding jumper is the same as the main bonding jumper in these separately derived systems. So 250.30A is your reference. There's your system bonding jumper in this application. There's your XO terminal. And you'll notice the lug down at the bottom of that transformer. And thank goodness they didn't put that over the vents, although all those conductors are right over those vents. I mean, it is what it is. Those vents are there for air to circulate up through. But that system bonding jumper is making that connection in this transformer, and that's typically where you're going to find it. You're going to find this in the transformer itself. So there's your system bonding jumper in your transformer, and then there's your first disconnecting means there. And again, we put service. System bonding jumper connection permitted at any single point. I like the images. Images are worth 1,000, and then that's where you're going to bond it again at that first panel board. So you're going to bring that neutral, that grounded conductor, or you can do that here. So in this case, what they're doing is they're not establishing that bond in the transformer itself. They're doing it at the panel board. You can do it either way. You can do it there, or you can do it down at that first panel board. Typically, for these transformer applications that are separately derived systems and not service applications, we're going to be doing that in the transformer. That's where I typically see it. I don't know about you guys and gals. I know I was doing a presentation one time, and I showed this example in my presentation. I talked about the grounding and bonding of a separately derived system, and I had somebody raise their hand. They said, we never see it that way. We always do it in the transformer. And that's very valid. Your system bonding jumper location, you have some exceptions. This is your exceptions. So we sort of have three. We have three exceptions there. I'm going to blow through that. So how about this one? How about this image? I like this image. Remember when you had the parallel sources? Let's take a look. What's Dawn got to say? Dawn says, my choice of the location of the system bonding jumper for a separately derived system is the location that results in the shortest grounding electrode conductor. You know, that's a very good perspective, Dawn. That's a very good perspective. And your grounding electrode conductor which is going to be used to bond to your grounding electrode, and whatever gets you there in the shortest distance, that saves you the most money. I like it. Only legitimate possibility for the additional rod may be manufacturer's or AHJ instructions, but it would still be required to be bonded. Yes. Now, and you know what? Honestly, Steve, I'm okay if you put another rod in, as long as you connect that as part of the grounding electrode system. I can do that. I don't have any problem with that. There's nothing that would prohibit that. Now, if you drove that rod and you did not make it a part of the grounding electrode system, that's a problem. But you can drive that rod, put that as part of the grounding electrode system, and you're good to go. All right, separately derived systems consisting of multiple sources of the same type, permitted to have the system bonding jumper installed at the paralleling switchgear, switchboard, or other paralleling connection. Now, this is the paralleling. Remember, we talked about this earlier. And you have your 3 generators, and we're showing one line for all 3 phases, but you would have A, B, and C coming off of each of those generators. So we're showing one line. It's a one-line diagram and a breaker, but then we're breaking out the grounded conductor and showing how all of that ties together. So that's a good image there. Yep, there's your auxiliary grounding electrode conductors. That's exactly right, Steve. Yep. And that's permitted. So now, in this one here, here's your... I like this image a little bit better. I think David or somebody had pointed out earlier. This image is really nice because you have your separately derived system. There's your grounded conductor, your 3 hot conductors, and we land in a piece of equipment, at which point We have our system bonding jumper. There's your grounding electrode and your grounding electrode conductor. You have your grounding bar, terminal bar, and that's bonded with the grounded terminal bar through the system bonding jumper. So I like that. And then you have your you have the proper grounding and bonding in that picture. And no wonder why it wouldn't work. All right. Your supply side bonding jumpers to bond the enclosures of the derived systems, etc. So we're talking supply side bonding jumpers now. Here's another half decent image. You have your panel board. Let's take a look. We have a separately derived system. So this one here, this is a nice image. You have your panel board on the high and low side. You have your XO. So this is just your bonding jumpers. This is interesting. There's your parallel secondary conductors, supply side bonding jumpers, supply side bonding jumpers. There's your grounding electrode conductor bonding the ground. That's an interesting. I'm hearing people talking here. Having flashbacks of Mike Holt boiling over auxiliary ground rods. Yes, you know what? Yeah, he doesn't like to sell. I remember him saying somebody had stock in ground rods or something like that. I guess that's where you should install wooden ground rods. Just saying. There's your here's your supply side bonding jumper. So another decent image there. So you have your separately derived system. Your XO is bonded in the transformer. That's where I typically see it at. And then you have this is what was made earlier. That if that's not a utility service, then you need to pull that supply side bonding jumper, and that's your physical conductor. Now, I believe you can use raceway in some applications. This one here, they're pulling a conductor through that raceway and they're bonding it from the transformer over to that panel, and that's your supply side bonding jumper. And you're going to keep your grounded conductor in that panel separate. You're not going to bond it in that transformer or in that panel board because you've already bonded it in the transformer. Make sense? So if a grounded conductor is installed and the system bonding jumper connection is not located at the source of the separately derived system, installed in a raceway, it has to be routed with the derived phase conductors, not smaller than what's in 250.102C1. You can use the 12.5% rule, and then it's not required to be larger than the largest ungrounded conductors. Dawn says, non-flexible metal raceways are permitted to serve as the supply side bonding jumper. Yes, I would agree. But you have to have the right fittings. And when I looked at that picture, I wasn't sure if they had the right fittings. So they could pull the conductor through, but you have to have the right fittings on either end for the proper bonding with the structure. And then in some cases, you might have to bond it. You might have to bond it at the fitting. Hope I got that right. Didn't it say the bonding happened in the panel board, not the S supply side in that previous image? I'm going to take a look at that image. Hold on. Steve says, and need a wire for the EGC. Yeah. So let's go back to that image. There's your supply side bonding jumper, where supply side bonding jumpers are run with the derived phase conductors. So this is your separately derived system, and the bonding is done right inside this panel. I don't know if I can, do this. I clicked the wrong one, but I still got the right thing there. So there is bonding done right here. That XO has 1, 2, 3 connections to it. So one of those connections bonds it here. One of those connections is connected to the grounding electrode. And then the other connection is this one that goes to there. And then from this terminal, I've got that bare copper conductor that goes through this, up, and connects there, and that's your supply side bonding jumper. Let's go back to live. Dawn says a supply side bonding jumper is required no matter when the system bonding jumper is installed. Absolutely. No matter where the system bonding jumper. Yeah. I mean, you know what? I accidentally did the did the zoom. I clicked the wrong one, but it worked out good, didn't it? Love it. Let me erase all ink on slide. There we go. All right. So I wish you know what I'm gonna do? I'm gonna move that down just a little. That way I can see the screen. All right, so we already talked about that. Man, I'm getting close. All right, so now this is your type PVC non-metallic conduit. In this case, you have your grounding electrode and you have your system bonding jumper done up here. So there's your system bonding jumper. This is PVC, non-metallic, so we can't rely on that to bond both sides. You have your grounded neutral conductor, and then we bond here to this enclosure. For buildings or structures supplied by a feeder from a separately derived system located outdoors, the grounded circuit conductor is permitted for bonding where there's no parallel path for grounded conductor current. So this is when you are using the grounded conductor, which is derived right here at the source of that separately derived system. That's 250.30A1 exception number 2. Isn't that beautiful? Now I can come down here and I can do erase all ink on the slide. Now this one here, okay, so this one here, you see how they did this? And this is what I believe, what we were talking about earlier, let's do this. They bonded with the building steel for this separately derived system up here in the corner. You know, there's no ground rod there, right? So that is how they did their bonding in that application. And then for this panel board, they bonded with the grounding electrode system as well, because the building steel, etc., is your connection point. So that that's what I would have expected. That's what we typically see. We don't typically see a ground rod being used. Thanks for zooming in. There we go. And that panel is bonded to the rest of the premises wiring. I'm assuming you're talking this panel here. So we're bonding. Now, you know what? Here's the question. That panel board, I don't need to bond that like that, do I? Dawn, Mr. Gannier, what do you think? I'm thinking about this panel board. I'm thinking about this connection right here. If I'm bonded from here to here, and this establishes my equipment ground, and so this is bonded, and this is bonded, and there's a bond here going to the grounding electrode system. I'm not sure I have a code requirement that says I need to ground that panel board and bond that panel board and take it to a grounding electrode conductor. The building or structural grounding electrode system to be used as the grounding electrode for the separately derived system. Oh, whichever is present, there it is. Whoa! Sorry about that, cats and jammers. Went the wrong way. And regardless of its nearness, I think they're trying to show two different concepts. One for the inside transformer and one for the outside. You know what? You're probably right. But it's not clear to me. It is if... yeah, there it is. If located outdoors, the grounding electrode to be in accordance with 250.30c, it is to be used to connect the grounded conductor of the derived system to the grounding electrode. Okay, you know what? Personally, I would have done this in 2 slides. That's the challenge when you're trying to give 2 messages in 1 slide. It's hard to read the slide. You need a guy like Don Gannier or Yummy Fudge or Steve or one of you guys to explain it to me. So in any case, I don't like multiple messages on 1 slide. And how we connect the grounding electrode is critical, and it's important that we do it correctly and we use listed equipment. Examples of clamps listed for the connection to building steel. So that's a good, that's a sweet little Hubble product there. Separately derived systems are an integral part of listed equipment. The grounding electrode used for the service equipment or equipment that is suitable for use as service equipment installed in accordance with the requirements of 225 shall be permitted to service the grounding electrode. So I think we have an image of that too. There's your bus utilized as an equipment grounding conductor for a separately derived system. That entire assembly is listed for that application, and that bus is listed for the application. And that's permitted as a grounding electrode conductor. So that still has to be your connection point to the grounding electrode. Don't you? I don't know about you, but I just love this stuff. And there's a lot of good resources in the SOARES Grounding and Bonding materials that are available from IAEI. We're having these discussions, walking through some of the images. There's so many more slides and dialogue and text that we're not going through during these little sessions, because these are like, the way I look at these 1 hour little reviews like this is like, wow, that was loud. It's like, teasers. That's what or infomer. This is like an infomercial for the resources that are available from the IAEI. And I am going to show you before we get done here that if you go to IAEI.org and you look how cool, and if you're not an IAEI member, you're going to want to be one. I'm telling you right now. You have a store. And if you go down, and I just go to the green. You know what? Why is green associated with grounds? Why is that? Why is it green? Why do we, I don't know. I don't get it. But anyway, SOARES Grounding and Bonding. Look at this. You can, oh, wow. NEC 2023. I love the images. And look at this, 50% off, 10% off, 17% off. And look at the newest members. We've got cool. Look at all that new member stuff going on down there. Look at all. You can go back to the 2020 and 2017. There's a lot of great references that are available from the IAEI. And when you become a member, I'm signed in right now, you can communicate, connect with other members, communicate, talk, chat, send emails, and just grow as an electrical professional. Don't forget to hit that like button, hit the thumbs up, subscribe to IAEI's YouTube channel, and participate in your local chapter and division meetings and your section meetings. I'm telling you, that's where a lot of learning occurs. Membership has its benefits. Like the graphic that caused confusion with multiple methods, or are both methods required? They're not both required. They are options. So, Steve, I am of the type that I like to have separate slides for each, but everybody has their druthers. Eli Markovich, grow every day. Absolutely. Every day, a little bit we learn. Now, hopefully you don't have a philo memory, first in, last out. So, I think your brain can only handle so much. So everything new you learn, you're going to lose something. And it may be that you can't find the keys to the car anymore, or you forget where your glasses are. See, that's my theory. I don't know if it happens to you, but it happens to me. Every now and then, I'll say, I can't find my car keys. Where did I put my car keys? Or I can't find my glasses. Where did I put them? That's the philo. I learned something. I hit my limit, and I forgot something. Now, the prioritization of what you forget is performed inside the brain. So we forget simple stuff like, finding your glasses and car keys. We don't forget the complicated stuff like, E is equal to MC squared and how to do Laplace transforms and things like that. So the next time you lose and can't find a set of keys, a pencil, your watch and things like that, it's philo. You learned something new. So celebrate the fact that you learned something. Don't celebrate or get discouraged that you forgot something. All right? You've got to grow every day. And guess what? I need to go to another meeting, which I am 6 minutes late for. So thanks for joining in for this little window into grounding and bonding. I got to think about next Tuesday. Take a look at the schedule. Maybe I'll go live on Monday instead of Tuesday. I don't want to miss a week. Got to get these weeks in, opportunities to learn, and I will try to make next week's subject related to the holidays. Maybe we'll do festoon lighting or GFCI protection and all that. I don't know. We'll have something that is festive, and maybe I'll get some eggnog and we'll enjoy some eggnog together. Eric Hammond, thank you. Don Gannier, thank you. Have a great day. Have a great week. Enjoy the week. Mr. Sandoval, thank you very much. Enjoy your holidays. I will see you before Christmas, though. Steve, thank you. Thanks, everybody. Take care. Stay safe. And remember, please, knock on wood, Joseph Violi. Stay healthy. Catch you next week. Stay tuned for a schedule change.